Hey, everybody. Welcome to the Flight Path, SDI's podcast on everything UAS. I'm Christian, your host, the event coordinator here. Here with James and Don from the UAS side. How are you guys doing today?
Real good. Real good.
Good. Sound
A
excited.
little tired. Outstanding. A little tired, but I'm good.
Okay. All right. So we're talking supply chain today, which is a very general term. And then we're going to go down and break it down into different things. But James, can you start out, just explain just briefly what supply chain is within the UAS space?
So it's a pretty big topic right now. It used to not be in the past, but recently, due to some changes, due to some announcements made by the FCC, which is the Federal Communications Commission, uh, there's been a much larger focus on it because, for those who are unaware, the Federal Communications Commission, or the FCC, has put out the announcement that there is restrictions to imports of UAS components that are not part of the FCC's covered list. So essentially, what this does is this heavily restricts capability to import components, not just drones. Because, and Don, correct me if I'm wrong on this has to do with everything involved in the on-crew aircraft system as a total. That's not just on the aircraft. That has to do with the things that communicates with it as well. Would you say that's a correct understanding, Don?
Yeah. Yeah, that's pretty correct. Pretty much everything under the sun, but mainly the communication systems. The FAA has to have some way to regulate the airspace, and one of the ways they can do that is by regulating the communication systems.
Yeah. And it's not just the communication systems, it's also the data that these systems have. So what we're seeing placed upon the industry is a very large restriction. Christian, imagine if all of a sudden say you have a camera that you like what's your favorite camera to use?
Uh, Sony A7 V.
Okay, so that's a really good example because where's Sony based out of?
America?
Hmm,
No.
no,
Yeah.
Japan, right?
Yep.
So one of their HQs is in Japan. So what if all of a sudden the FCC came out and said, "Hey, we're no longer allowed to use any cameras that are not American-made cameras"? What does that lead us to? How many camera makers are stationed here in the United States that produce and manufacture their cameras in the United States? Put a bit of a damper on things and make it harder to get upgrades to do different things, is to get different cameras, or it vastly scales down your options. And when you get a vast scale down of options, what happens to the options that you have left?
You run
Prices
out.
go up.
Prices go up and you run out.
Yep.
You're both
Mm,
correct. I'm loving
There
this,
you
hitting
go.
the target dead on. So that's what we're currently experiencing with the drone industry right now. And a lot of that is more on the NDAA side, or blue list side. And when we say those terms, we mean more about the defense, public safety, law enforcement side of things, because there are a few companies in the United States who can produce and manufacture drones and drone components to be compliant with those meanings. But it also, that FCC covered list has also put a restriction on even hobby grade components, right? Things that you could get that aren't necessarily being used for defense, law enforcement, or public safety reasonings. Understandably, why you want to do that, to protect people's information, protect those organizations' data that they're using the drones to fly for. But for those who are learning, for the hobbyists, for the commercial companies, it's becoming a bit harder to get access to those things. Sorry, I see you got a hand raised, Christian. What's up?
Well, I just want to take a step back a little bit because I know a lot of our viewers and listeners are our students. And
Hmm.
so some have some drone experience, some don't.
Yep.
We have quite a few folks that go straight from our firearms program into the drone program as well because they're interested in that. Uh, I want to break it down as far as supply chain goes. What are the different components of the different systems that we need to worry about that are going to be restricted, but we need that first base knowledge of what goes into supply chains for drones?
Don, I'm going to let you start out with that one, and then I'm going to come in after a little bit.
Yeah, it's a multitude of different components, right? I mean, let's step back before colleges became curriculum departments in UAS. Before all this, people would hop on YouTube, they'd watch some videos, they'd learn some stuff, and then they'd go order some parts, right? And the parts that come in are they're an electronic speed controller, or it's an airframe, or it's a camera sensor. And all of those components are put into a drone and then you assemble it. So to break down a drone basically is an airframe. You got motors, you got propellers. Those motors connect to an electronic speed controller. Those electronic speed controllers connect to a flight controller, which controls the algorithm for spinning the different types of motors and controlling it in the air. And then obviously you have your battery plugged in. On top of that, you have some accessories like GPS compass, um, telemetry units, and camera sensors so that you can get live video feed. All of those are accessories that plug into the flight controller. The flight controller is mainly the brain of the entire drone, and all the other accessories and peripherals connect to that. So in the past, it's been really easy to get those parts before this, FCC thing and introduction of curriculum in college courses. It's been relatively easy, but now we're crossing that threshold where like drones are in the air, they're not going anywhere. The FAA has to regulate this airspace. And so they're really pushing to be able to do that. And as a result, it's been hard to get or source components from where we have usually sourced the components from. It's becoming a lot more difficult. And
And
I know James can hit on
yeah,
that.
to tag on to that and to add a little bit more, Don's right. It's becoming harder. Not just it's for everybody who's involved in the industry that's a builder or a developer to source components. Because right now, a lot of our manufacturing capability is outside of the United States. We may have designed motors, we may have designed ESCs, we may have designed flight controllers, but because of the price and cost effectiveness of manufacturing overseas, because of a ecosystem that doesn't really exist at a large scale here, we have now have most of those components being restricted because they're manufactured. And as Don said, there are those components themselves that build a drone in and of itself, but it's also even down to the source of the materials that they build the PCB out of, the programmable circuitry board. It's down to the materials that are allow them to make semiconductor chips or transistors or resistors and all these small little components and stuff that we cover in UET 102 that make up these larger components like electronic speed controllers, like motors. It comes down even to where do we get the raw materials from? Are these things produced stateside? Are they manufactured stateside? Are they within our own boundaries and manufactured here? So if they are, we can have those access to them. But that's the level of what this goes down to. It's not just the individual drone component, it's about all the individual components that even make up one of those. Like an ESC can consist of almost 50 to 100 parts of those little tiny microelectronics that are placed on those boards. That's a lot of different pieces to try to source
Yeah.
from one location. So that kind of summarizes or puts it down a little more of a micro level of like how far this spans. Because if it was as easy as, oh, just this component, it wouldn't necessarily matter where those subcomponents come from, but it's also the subcomponents and where the raw materials come from as well. Even down, it's like people are asking about, well, how does a motor have any data or information? Well, it's not just about the information capability. It's okay, where are the magnets and the motors coming from? Where are those produced? Where are those sourced? So we're getting down to the very minutia of every component in the system that is now making it a little harder. Well, I say a little too loosely. Let's say a lot harder for many people to get access to components that they used to before for the supply chain, because most of it has been from external sources outside of the United States. Now, and understandably so, we have to ramp up really fast in order to meet, because what we have is a balancing act here. We have the defense side and restricting that for the FCC, of course, but then we have everyone realizing the need for drones in the Department of Defense. Department of War, and then all the other commercial applications. Because the more it gets popular, the more it spreads, the more people want them, the more people need them. So, and then there's more development companies that try to meet the demand of, hey, we have to have our own drone capabilities. Well, a lot of drone development companies up to this point have primarily relied on getting and sourcing components from other companies or countries. It's called a cost of goods list or a bill of materials. They can get all these different components, put them together, make the drone work. Now they have to think about what flight controllers are being produced in the United States that we now have access to, or who's producing them. What ESCs are built in the United States, what motors, what power distribution boards, what batteries, even what airframe components are. Airframe components are a little easier to come by because of carbon fiber and CNC machines and also 3D printing. Makes it a lot easier to get access to those kind of components, but it's really those electrical components that make it challenging right now for us.
Do you see any changes in the future of stuff getting better? Or what's your outlook for it?
I saw a little bit of hesitant, resistant face on Don, so I'm very interested to hear his take on this.
It's interesting. We're kind of at a double-edged sword here, right? I mean, the industry, so long as they can get and source parts from outside sources, foreign industries, wherever it may be, there would be no need for change, right? They can get your cheap parts, keep continuing operation, and go about their business. But unfortunately, we we have to make a change. Like, we have to support our industry in the US. And frankly, it's hard to say, but the only way to really do that is to limit the supply from foreign imports. And you know, we don't really have the infrastructure that we have relied on so long to build these drones, and now being forced to create that infrastructure, a lot of small businesses are going to suffer from that because their entire fleet is built around that whole entire ecosystem. So it's going to be a growing pain. Do I see it getting better? Potentially, but it's going to take a long time to build that infrastructure to get to a spot where we can rely on ourselves to create this manufacturing demand here in the US.
Take a little bit of this is a serious matter, but I want Lord Farquaad. Some of you may die, but it is a sacrifice I am willing to make.
Yeah.
But in all seriousness, this is a critical issue, and Don is exactly right. It's the force of hand, if you will, because if we continue allowing some access to something, we will continue to go the route of the ease of access. We won't develop our own capabilities. We won't further our own capabilities internally as an industry or on the patriarch side as a country, right? So this is needed. It's a hard thing right now for everyone. It's hard to deal with. It causes difficulties. It causes concerns. It causes stress. Understandably so. But it's not just the drone components side. It's even all the way leading down to the manufacturing side, from those who transfer raw materials into those components, the sub-circuitry components, to the pick and place machines that build these PCB boards that make them how we're familiar with them with flight controller boards. If you open up the Pixhawk flight controller that we send in UAS 213, what will you see inside? A multitude of smaller processors and resistors all laid out cleanly on this board. And we don't have a large capacity for that, and we need to expand that. The good thing about this is on the opposite side where the funding comes from on the drone dominant side. Now, granted, drone dominant side, and correct me if I'm wrong on this, Don, that is mainly for DoD and defense, though. So there is some support there, a really good amount of support for the development of drones and the supporting of supply chains for Department of War and public safety and other things. But when it comes to commercial side or the hobby side, feeling a little bit of a squeeze
We're
right now.
getting pushed to the wayside.
Just, I want to say completely, but right now there is a primary focus uh, in comparison to into the larger set focus and other parts of the industry for sure. And this is more of a call to action. This is something of, if you or anyone listening to this has the capability for, or knows how to work with raw materials, or knows how to manufacture, even just on a simple CNC machine for airframes, or has ever been interested in electrical engineering, or has ever been exposed to putting components on a programmable circuitry board and wants to look into that stuff and know how to understand it, or has that knowledge, you're going to be critical right now, because we need those individuals who know how to manufacture and process those things, uh, and even to the demand of developing it too. Because if you're a developer in the UAS industry, you can trace back that supply chain. And if you can trace that supply chain, you know where the weaknesses are, and then you got to find where the holes are, and then work with others, work with companies that either exist or are yet to exist that you can maybe entice to get into the industry. Because this may be saying it too much, but I'd say getting in as a manufacturer right now, if you can make semiconductor components, it's kind of a guaranteed business at this rate. It's almost a steal. But I'm curious on now, having a little heard about it a little more, Christian, what your thoughts are as far as, a non-familiar view looking inside. Like, now that Don and I have explained this a little bit, my question to you is, what's your true take on this? What's your thought about it? What's your generalization of it?
Well, as a hobbyist, I, and somebody new, I don't see it as much just because I have the availability to, I guess, lower class drones, either older drones or even some newer drones that, have good capacity of doing stuff, but it's all kind of plug and play stuff. So I'm not building my own drones. I don't have to source anything from anywhere. And so it might affect those who are more into drones than I am, that are actually building them for a specific purpose and not just flying around just trying to get one wheel shots of the drone following me, you know, or something like that. But
I actually, Don, I think Christian's onto something with that, because while we may have our ear to the ground in the industry, there's also the conception of like, who does this really affect? Does this affect the everyday hobbyist? Does it affect the normal hobbyist? Who does this affect on the hobby side? Is the hardcore guys that has to build a new drone every month? And then does this affect existing companies that already have aircraft, developed and put in place? Maybe like companies out there, just to name a few, like Inspire Flight or Skydio. Does it affect them, or does it really only affect the numerous amount of companies that are starting up that are still either developing their aircraft or developing part of the system? Maybe they are a parts developer. Eh, I'm curious. Like, do we narrow it down a little bit, or does it still affect everybody at the same scale? I think it's a narrowed down point, but I'm curious on your take, Don.
I'm gonna say it's all of the above, but more specifically, the small businesses that rely on the entire ecosystem that they have been relying on to do whatever it is they do in their business. Those are the companies that are going to be affected the most. For example, I have a friend down in Phoenix. His entire fleet is all DJI products, and he had to drive to Canada to get to his mom's house because his mom lives in Canada, and have the drone shipped to Canada, the Mavic 4 Pro, just so he could get it and bring it back into the United States. I mean, it's those types of people that are going to be affected the most. And frankly, it's a very hard pill to swallow for us hobby guys, because not me in particular, but we as hobby industry experts have propelled this industry forward and allowed advancements. And now it kind of feels like us, hobby guys and small businesses are getting pushed to the wayside, and we're just being forgot about. But at the
Sort of.
same time, there has to be a way to regulate the airspace, and I understand that. I understand that.
I think we have to define what's a hobbyist, because to me, a hobbyist is somebody who's just tinkering. And for drones, not even tinkering, because I'm not doing anything except maybe changing a propeller on this thing. And if I need something else, I'm taking it to one of you guys or doing something else. But I feel like between hobbyists and like what's an enterprise? I don't know the different levels, like enterprise level drones, business, commercial stuff. I think that would be more of the class of like the lowest class that gets affected rather than me who can I can be fine with a whatever, a Mavic 2, and do what I need it to do, I have
Christian,
something
you're always
better.
here, but right now
Yeah.
I'm just really glad that you're here because you're putting it into the right perspective. Because you're right, we're overgeneralizing a little bit when we say things. When you narrow it down, you're right. Like even on the hobbyist side, it does come down to certain like levels. Like, are you a hobbyist that bought already to fly drone, something that's pre-made, you don't have to build, maybe you got
Mhm.
to replace the props on? Is it a large effect on you? If you go out, maybe you're using it on vacation, maybe you're using it for the occasional cinematography thing, but it's not in dangerous environments. You're not crashing it all the time. It's once in a while, and you have some spare props. Well, then yeah, you're not going to feel that effect until, of course, you completely crash your drone, and that drone is out from outside of the United States. Now, if you have a small fleet of drones as a hobbyist, well, then it's not that big of a deal because you got a backup. But if you have one and you liked it and you want another one, now they're going to be a little bit harder to come by. Now, to the other I like how there's two sides of the hobbyists. There are buy and fly, and then there are the builders and those of us who freak out about PID tuning or proportional altimeter derivative tuning that stabilizes your aircraft, and we get all excited about it because, ooh, I can tune this thing to perfection for how I want to fly it. So it's those on that side of the hobby,
Okay.
the builders and flyers, and those in the FPV scene, the first person view scene, the racers, the cinematographers that build those aircraft. And honestly, most people normally have a fleet of those, a small fleet, and they have more than one. And in most cases, at least from my exposure, there's always, the individuals like myself who has at least one of those. But those are ones that you either, you buy and then you buy into it and fly it, or you most of the time end up building it yourself from these different components sourced from outside of the United States. So those are more the hobbyists that are definitely having a larger feel of effect than someone who, bought something, has a few spare props, not going to be in a lot of dangerous situation, and then they can go and try to find an alternative. I think we mentioned it in another podcast earlier when we were talking about like the possible bans of the future that are now in place because of the FCC list, is that it is going to make it harder to get a replacement. That's the only other side of that. When you say on the enterprise level, it gets challenging there as well. Because unless that enterprise company has already sourced or made sources for their components internal to the United States or with a partnering country, um, like any of those in the EU, then guess what? They're okay. But if any of them were using source components where I would say a good 80 to 90% of your SUAS components are coming from China. So, but I'm also curious with that different perspective, Don, what would you say? What would you say to that now, as far as that different define it? Would you agree, or do you have a different thought process on that? It's a harder one. It's a tough one.
Yeah. I I don't know. It's kind of lost my train of thought. So what were you talking about when it comes to components?
So what we're talking about is it's not even the components. It's the real like who actually is feeling the effect. We're generalizing. We're saying commercial. We're saying hobbyist, but there's different kinds of hobbyists.
Yeah.
There's the individuals like Christian who has a drone and has replacement props. He can get up, put it up, fly it, buzz around for a little bit. There's very low risk that he's going to crash it because he's a competent pilot. But then there are the other side of the hobbyists like us who are builders, where we build, we tune, we tweak, we fly. And then there are the commercial side who are either always building or even like what Christian said, there are commercial companies that just buy the drones and then they just fly those drones. They don't necessarily build them or have to have the source or apply them. So I think I'll narrow down the question a little bit better so to help. Are the buyers of drones that already have a fleet feeling the effects on a large scale, or is it more of the drone developers and builders?
Well, I think anyone that needs to source components, be it components or drones, if you do not have a backup, it's just going to become more difficult for you to get parts. Whether you're a builder or you're a prosumer guy running a small business. If you need additional parts, whether it be a drone or components, you're still going to have a difficult time trying to source those components.
And I guess we get down to like a trickle down effect, right? And what I mean by that is for those who build drones or already have drones here in the United States that they can sell to others. Now, all of a sudden, with this shift, with the FCC covered list and the restrictions being placed, they're having a lot more customers than they probably planned for. So they may have large backlogs, unless again unless there are those that have prepped for this. They may have a large backlog. So maybe you order a drone that's 3 times the amount that you would normally pay, but it's of the same quality or better. And but now you have to wait 3 to 4 months because there's a manufacturing backlog. So you'll still get an aircraft. It's going to cost you more. You're going to have to wait a bit. You're going to have to wait longer, which is going to affect business. So yeah, that is a bigger trickle down effect that still has an effect, even if you're just a buyer of a drone. Again, that's more on the commercial side. Hobbyist side, if like Christian, if you didn't have your drone right away, would you need one in the next 2 weeks?
No. No.
So hobbyist side, not a big effect. Commercial service providers like that use drones as tools, or maybe companies that are not like UAV services providers that like say wind farms that are having their operation and maintenance personnel on site learn to fly drones and they use them for inspection. If they crash one, well, yeah, well then now that capability is gone. So we may see some conversations going around if we can't ramp up as a country fast enough to meet this new onset of demand that we've uh, created ourselves in a way to have to refer back to old methods that we used to have to do before we had drones. So there'll be some time where we have to do that before the industry actually ramps up to meet the manufacturing and demand. But hopefully that's not the case because I think there's a lot of individuals focusing right now on, okay, now we have this new problem and it's unilaterally slapped us in the face. We have to deal with it. We have to address it. So it's it's a big issue. So my question for Don on this is just from what you've seen out there in the industry and your connections and contacts, what do you think is a realistic view or a realistic timeline before we get back to normal? And this is purely speculative. Obviously, we can't be fortune tellers. That we all know this for sure, because this as a systems problem is bigger than any one person that can look into and have a really good picture of. For those listening right now, we're talking about the possible effects and scale and trying to break it down for those who may not have seen or heard of this before. But for anyone to be able to break it down and say, "Oh yeah, in 2 years we'll be fine again," don't listen. there's no timeline that can purely be associated with this. But guesstimates, give me guesstimates, both
I,
Don and
I
Chris.
don't think there's I don't think there's a timeline that you can place on this. Um, that being said, I do think we're making somewhat of progress in the right direction, but I think that progress is mainly geared towards the Department of Defense. Like that's why that Drone Dominance Act is out. So everything is going to be pushing their efforts towards that area until it's, kind of rock solid. And then, we'll get the trickle effect on the hobbyist side or the prosumer side or the small business side, right?
Give us
So,
an example of that. What are your examples of how you were seeing progress on the Department of Defense side and Department of War side?
well, I mean, Androl's a prime example. I mean, they're scooting right along just fine, and they have the support of the government. They're doing something a little bit different than, let's say, Boeing or Lockheed Martin, where they bid for contracts. Like they actually have products, and they go out and they sell these products to the U.S. government, and they advance their AI systems and drone systems to meet that demand. And I think that's why they're so successful because now it's just not a matter of fact of bidding between two companies and letting them come up with the best product. The government can actually go to Anduril and they have a product that suits their need and they buy that product in bulk or whatever they do. And the industry continues to move forward. So Anduril is a prime example of someone that is supporting the government in that area.
Palmer Luckey was really forward looking on
Yeah, he was.
started Anduril. That I will say, because they got ahead of it. on that marker. They planned well before a lot of this was being discussed or determined. So really forward looking on that part. But there are other companies out there. Like everyone knows about Skydio, everyone knows about Brink. There's also companies like Firestorm Labs, who also recently announced a partnership with Orca, actually. And Orca's out of Croatia. But Orca has components and they're NDAA approved components too. So good part there's companies out there that work in the defense space that are finding partners, working with others. They're not just trying to take on the challenge themselves. And there's going to be a big benefit to that because of how well they make their system or how well they can create something that works for the Department of War. But I really like this is why I was kind of shaking my head and getting giddy about it because I really like your analogy, right? The idea that the Department of War, the Department of the DoD side, the DOW side is going to get a lot of the focus at first, and we're going to have a trickle down. What other time in our history have we seen that happen with a lot of technology? Can you think? Can you think about that? Starts with a W. World War II, guys. World War II, what happened? America ramped up its manufacturing in a large scale. And it's not just to the fact that we had to create more capacity to do new things, it's that we also looked at what we had and then we said, how can we make weaponry to support the warfighter that we can use our existing capabilities and then expand on those capabilities? And where's the funding to do that? Well, anytime war defense focus comes along, there's some funding that comes with it. So we're seeing somewhat of a repeat effect of that right now, but it's not on the massive scale like we saw in World War II. It's not for a multitude of industries. It's not for shipbuilding, steel barrel building for warships. It's not for aircraft building. There's not for munitions and firearms building. Like it covered all facets back then, and not just the tools, but also the materials, the food, the supply lines, everything. Right now, we're seeing a small portion of that kind of being repeated, but for drones because there's a lot of funding in the drone dominance program. So now the drone dominance program is trying to help fund the development of those production capabilities, which when they've met their goals or a time of which those are no longer needed or the scale has gone past the capacity required, like you said, Don, we'll see that trickle down effect start to happen. And when that happens, like we said, it's a guess on everyone's best part. But that's where we're at right now. It's we gotta I hate to say wait and see. You can wait and see, or you can become part of the solution. Learn more, do more, understand the industry's challenges, really dig deep and find where are the points that we don't have, where are the capacities and capabilities are we missing out and what we need. Because there's companies out there, like I said, outside of just drone companies that we know of, there's companies that exist here in the United States that are United States made components. Max Amps, they're a
Yep.
battery company out of Spokane, Washington. They're in operation. They can do a 10 to 12-week lead time and on a large bulk order of batteries, which is pretty impressive. It's made here in the United States. Motors, it's a little more harder to come by. We don't have a lot of magnet producers from raw materials to magnets, but there are more companies that are making PCB designs, flight controllers, ESCs, power distribution boards. So those components are coming along. So we're slowly seeing that demand and manufacturing people coming into play to solve the issue. But we need more than just what we're seeing now. We need tens, 20, like hundreds of this to really meet the demand and the growth capability of what most people are picturing as. But yeah, it's really interesting to see where we are right now. It's gone from its promise, and now there's this huge mass adoption, along and paired with restrictions. So mass adoption along with paired restrictions creates that tension, a lot of tension. So yeah, that's my thoughts on the process.
Well, I want to take it back to the hobbyist because, with our students and our viewers, folks who want to turn from me, who just occasionally fly a drone, and then turn into you, that gets excited about tuning and, everything, the drone to their specs and what their uses are for. How do these folks source it? Is there like a main website you go to? Is there an Amazon for, drone supplies? Are there three big websites? How does all of that work? And how can a student go from me to you as far as sourcing and grabbing the components that they need?
I'm going to start off by saying just one thing. When you build a drone, it's not just putting the pieces together and building a drone. It's more so understanding the system. Once you have an understanding of how the system operates, you can make better decisions on the choice of components that you want to put on there. And I think that's the important part that most hobbyists getting into the industry should know, and what we cover in our UAS 213 course.
That's one of the big things. And Dom started off right. We do cover that in UAS 213 because part of being a builder is knowing where to look, knowing how to build out a bill of materials, knowing how to look at the specifications of different components and making sure that they work together with one another. Like, for example, you can't just go and buy any electronic speed controller and expect it to work with any motor. You have to make sure that the electronic speed controller and the motor have the same range of S rating or cell count rating. That's okay. Well, this thing handles 4 to 6 cells, cell counts. Well, then I got to use a 4 to 6 cell battery. So now by choosing these, I'm limiting my availability to choose and what I can choose for another part. And it's not just there is not a go to one size fits all marketplace for building a drone. Actually, idea for listeners, if you can put that together for a hobby side and literally put everyone in there and make a build your drone software, you'll have a decent amount of investors. But in any case, actually I might take that. But in any case,
Say patent pending, and then,
patent pending. Sorry, I'm putting up free money making
yeah.
ideas here for people. But in any case, you have to go and search. You have to know names of brands. You have to look around. Like, you have to go to sources. Like getfpv.com has a multitude of, different manufacturers that they sell from. There's, there's E-Flight, there's Horizon Hobby, there's Cobra Motors. There's a bunch of different manufacturers that are either specialized in different set components, or at least one component, and they have a multitude of selection of them, or they have the complete package for you. So to really transition from, hey, I'm just going to go and buy a drone, to being a builder, there's patience. And it's not just patience and looking around and, finding the right specs, but also understanding how these puzzle pieces are put together. But it's not just the shape of the puzzle, as Don mentioned before, it is the technical underlying specifications. Because if you just get a modge podge of different components and don't really check the specs to make sure they work with one another, your drone is either going to pop and it's not going to be fun because you're going to smell some magic smoke, or it's going to take off and flip and do some wild stuff. So you
But
got to be.
that's why you
Sorry.
come here, get
Yes.
your, learning in the right order, develop a foundation, know what you need to get, know what needs to go together. But then hopefully, I don't know if you guys cover where to source the parts within the curriculum, but I'm hoping you do, because I've never taken the program. But that's why you guys are here. So where would
Well,
that be covered?
yeah, that would be in UAS 213. We give examples of where you can find the different components that you're looking for. And then one of the big things we really rag on is actually how to find the specifications for what you're looking at. Because like I said, like the example with ESCs and motors before, that's really important that you check those and look into those. Look into the product specs, understand how that reacts with the rest of the aircraft system, which is why you're going through the build, because the best way to learn is by doing. And that's what we like to do, is send you a kit so you can actually get that hands-on experience to learn, put that together, as well as not just do it, but do some troubleshooting along the way. Because more times than not, when you're your first time building a drone, from just the knowledge that you gain, there's going to be some troubleshooting. Stuff doesn't always work perfectly on the first go. So you learn some valuable troubleshooting skills along the way, and it's better to do it in a learning environment where you have that support than to necessarily just do it on your own and try to deal with the frustrations on your own, right? there's a lot of great resources, not just here at SDI but outside of SDI as well to help with troubleshooting. But we like to structure it in a way that makes it a little easier when you're first doing it. So that way, in the future, you can take this first successful build and now apply that knowledge to building your own in the future, of course.
Sometimes if you don't know anything about putting a drone together, it's nice when someone can hold your hand and walk you through it. And then at the end, you get a product that works as advertised that you can learn from and draw from your experiences and then go out and branch and start building or sourcing other components based on, a baseline that you have built.
And one of the and sorry, just to add one last thing for UAS 213, one of the underlying importances of that course is not just the knowledge of building and having built something successful and flying it, but it is also and I mentioned troubleshooting, it is also understanding the process that when you first build something, it's not always likely that it's going to work the first time. So how do you learn a process that allows you to go through it, understand it, see where an issue is? Okay, come back. What part of that setup went wrong? How do I redo that portion of the setup? Or is the component working as I need it to for this system? And then say, okay, what do I change? And then once you've made that change, go back out and follow that same testing process again. Because if you don't know how to accurate, or if you don't know how to really put it through a test process and think to yourself, how do I find the issue? Or like what is considered working to me and what's not considered working to me, then you're going to have an even harder time trying to get something to fly when you're building a drone for the first few times. I want to say it took me a good 4 or 5 quadcopters. Like I had a lot of experience building radio controlled fixed wing aircraft, but it took me a good 4 or 5 quadcopters with like APN and multi-wii and open pilot before the first time, before I got to a point where the first time I flew that thing, it worked as I expected it to. Every other time I've either flown it, it's flipped, or it's been unstable. I've had to go back and troubleshoot. I had to go back and tune. It's a natural process. It's easy for us to get frustrated when it's our first time going at something, but it's a natural process that all drone pilots, both commercial and hobbyists, go through of figuring out what's wrong. How do I learn more about it? How do I fix it? How do I make it work the way I want it to be? And I'm sure I'm not alone in that endeavor, Don.
Yeah. I mean, I could talk about my experiences, but I definitely blew up some components when I first started. Yeah, for sure.
We're popping capacitors. We're
Yeah.
taking cable leads off motors, cutting PWM servo signals. Yeah, all that fun stuff. It happens. And it can even happen to those of us who are experienced too, especially when you're trying a new configuration that maybe you haven't tried before. Maybe instead of building a quadcopter, you're building a octocopter with 8 motors instead of 4. And maybe one of those PWM servos got wired backwards, it can happen. So, anyways,
Yep.
sorry, Christian. I'll
Well,
stop.
no, I was just thinking about because you worked on drones that you were developing for, drone delivery, where you're burning up drones that are like tens of thousands of dollars. So
Mhm.
at least,
It's
us
it's
hobbyists or those hobbyists are, maybe a couple $100 out of out of pocket.
it's much better to learn on the smaller ones, I'll tell you that much. When you get bigger, they do get a little more complicated, so there's still some things you don't always catch right off the bat. Like for example, I learned that backfeed voltage from a motor can short circuit and overpower a flight controller. What I mean by that is when a motor is spinning fast and a bigger one at that's like takes 50 amps to spin, if it stops or slows down, well, it's freewheeling. When it's freewheeling, it's actually sending a power load back through its cables. And that can lead all the way through to the ESC, which is then connected to the flight control board. So if that flight control board can only handle 3 to 5 volts and this thing suddenly puts 50 volts back through to the thing, it's like your computer just shutting and going off and going blank on you. But instead of, being on a desk, you're in mid-flight. So,
And
okay,
and
we
I
learned something new about the system. What do we do to prevent that from happening?
wanna I wanna clarify, you said something about backfed voltage,
Yep.
and unfortunately, uh, in a drone system, that's a necessary evil for the
Yeah.
drone to actually work correctly. The only way the electronic speed controller can tell the the position of the bell in relation to the stator is when that bell passes a magnet because electromagnetism sends voltage in the opposite direction. And that's what the ESC uses to determine the position of the bell in relation to the stator and when to fire the next series of coils.
Yeah.
It's a necessary evil, but there's a way to reduce that amount or filter that voltage, that backfed voltage. And one of the ways that most guys that have built drones before, or at least a few of them, know that you got to have a capacitor on your ESC, right?
That or Schottky diode.
Yep, true.
Schottky diodes are little devices that when a certain voltage of a certain value is higher than what you set the diode for, it prevents that voltage, that higher amount of voltage from getting through, and it acts sort of like a capacitor, but instead of, setting a certain voltage value, it downgrades it to the level that is acceptable to be sent. So yeah, capacitors, Schottky diodes, those two. And I mean, Don just put out the perfect example for us of why UET 102 knowledge is important. Fundamental electronics, because all these components have to deal with electricity in the system. So if you don't know much about electronics, we're not going to have a fun time, to say the very least. But good point. Good addition to that, Don.
Is that how hybrid cars work?
That's a good point. There,
Like when you slow
I mean,
down, I feel like I don't know all about it. I was just reading the manual of my wife's car. I was like, oh, that's kind of interesting because I never
what
really
kind
knew
of
how
car your wife
hybrid.
got?
RAV4 hybrid.
Oh,
So
that's
Okay,
what
I
we're
was looking at one of those. Those look pretty good.
you should get one. But then I was also thinking my one wheel works the same way. Is they say if you're on a full battery, don't go primarily downhill because
Mm-hmm.
there's backfed voltage or whatever, and
Yep.
it'll burn your battery that way because
Yep.
it's not power. It's whatever you said, free flying or whatever it is,
Uh,
just down the hill, and it's not using any of the motor to generate any speed or power.
yep. And essentially, what it's doing is almost giving your battery a little bit of charge back,
Mm-hmm.
almost in that case, because they might not have something to prevent that backfeed from getting to the battery. So yeah, in that case, it's very real that, oh yeah, the battery's suddenly overcharged, and now those cells in the battery pack expand and just big fireball.
if
Not to
if you're
scare you,
which is
but
which is fun. No, I'm doing it on purpose.
it's already
So
hot enough in
yeah,
Arizona. You just get a little hotter.
yeah, it's true.
if you're a listener and you can harness the power of that backfed voltage and feed it back into the battery system, well, I think you got a pretty solid
That's how
business
you turn
plan.
into Iron Man.
Yeah.
So no, I don't.
Right? If
Right.
if only someone could figure that out to where it's a perpetual motion machine for electric generation, but on a drone that's flying, and have it fast enough where you can charge and discharge at the same time without overheating the battery. That's another factor. Think we're getting a little bit too deep in the weeds, but yeah, like you said, Christian, like one wheel car, like it's a similar way. But I think for cars, because of the larger voltage, they have to have some level of protection in place. They have the regenerative braking, which is using that additional magnetic strength to say, okay, I'm going to take more of that. I'm going to use that momentum to generate more charge. And then it has that little trickle charge. It's a very, very small amount back to the battery. But they have a way of doing that safely because they planned for it as part of the design as like an additional, like, here's how you get more miles feature rather than,
Have
just
you
that
guys
little,
ever
sorry.
driven a Tesla at all? Has anyone driven a Tesla?
I have not.
No?
Not a Tesla, driven an Ioniq, though.
Okay.
And then no, Waymos aren't fully electric, so never mind on that.
The Teslas I know have regenerative braking, and I only mention this because my previous boss had a Tesla, and he would try and time it so where he let off the gas, and it would slow down and stop just behind a car, so he didn't have to use his brakes.
Yeah.
Uh, but it was interesting.
Like a little
He's always
game. He's
trying to
gamifying it. Just
time.
and he only rear-ended 3 people, so that's fine.
Yeah, right.
Anyway, so we're running into time. I want to hear final thoughts on just basic supply chain stuff from both of you. So who wants to get it started?
Go ahead, James.
All right. So, supply chain currently, as it stands right now, is a challenge. Again, call to action here. If you know a skill that helps with manufacturing or production in any way, you could be of assistance in this part to rapidly expand the capabilities that we need right now to support the large amount of growth needed to be a supplier in the uncrewed aircraft systems industry here in the United States. Not just here, because there are companies abroad that would also like what we produce as well. We can be an exporter, not just an importer. So if you have those skills, be a good chance to an opportunity to use them. Look into it, do some more research for it. Look at the FCC cover list to understand it a little bit better and more information about it. And then for those who want to know more and how it affects them in the UAS industry, for those of you listening that are UAS professionals or getting into the UAS industry, this is something that will benefit us in the long term over time. Uh, we're going through it right now. In some areas, it has a large effect, as we discussed. Others that we don't. But it is imperative to learn about these, because when we understand not just drones and how to build them in general, but also where their components are sourced from, the supply chain leading up to it, we as future designers, developers, current, future, past, can understand and be forward thinking and future thinking of, like what a lot of people are doing now because of the immediate kind of slap in the face effect we're getting right now, to plan for that and what happens and how we need to build that substructure that allows us to be able to build the capacity that we need to right now. A little deep, a little long. Sorry about that. I'll pass it on to you, Don.
And maybe
Yeah,
you can also be the new Andril or whatever, the future Andril.
That's gonna be a hard one. Paul Erlicki's was CEO of Oculus, and now he's doing Anduril. So that's a good challenge, though. Drive yourself to get up at that level for
There
real.
you go.
Give it a shot. See what you
All
can
right,
do.
Don, final thought.
I mean, James, you said it best, honestly. But if you're looking to get into the hobby, into the industry, or into the manufacturing space, the best thing you can do is just get started. Like, just make that plunge, make the effort to get started and learn some knowledge, because knowledge is power. So you can join our program, you can hop on YouTube, you can watch YouTube videos, you can source components and try and build your own drone, whatever it may be. If you're looking to get started, now is the time. Don't wait. Don't put it off. It's going to be worth it in the end. If you set a goal and you hit that goal, you're going to be stoked.
Man, that's
Hey,
a softball pitch right there. So if you are wanting to learn more about our programs, go to sdi.edu, hit request information, talk to one of our admissions reps, go through our curriculum, go through our funding and tuition option stuff. Just get started. So, but that is today's The Flight Path. James, Don, thank you. I've been Christian, and everybody have a great week. We'll see you next time.
you too.
Bye bye.
Bye-bye.